I welcome to all to the course of repair and rehabilitation of structures. So in this session, I will be explain what are the uh, topics in repair and rehabilitation of structures. So in this session, I will be explain one of the topic in Unit 2, that is repair to masonry and concrete structures. See, what are the topics is there in Unit 2. There will be related to masonry structures, and there will be related to concrete structures. What first Before going to discuss about the repairs, first let us know what are the major damages in masonry structures, and what are the major damages in concrete structures. Let's will be discuss the first one, what are the damages in concrete structures. So and will be explain how the damages will be occur due to what reasons, and there will be a three basic symptoms of distress in a concrete structures, which means there will be a three types of major, we have a lot of types of damages is there, but the three are the major distress or damages in concrete structures. Those are cracking, spalling, and disintegration. Cracking is nothing but it is a fracture, it is a fracture, or it is a breakdown of concrete structures. Spalling is nothing but it is the separation of layer from concrete structures, or removing of one part of layer on concrete structures. And disintegration is nothing but it is the separation of a particle from in a concrete structures. For example, the concrete is removed and the steel will be exposed to the moisture conditions. So that those are the three major symptoms of distress or disintegration in a concrete structures. See how why what is the reason of these type of damages. There will be a lot of reasons are is there, due to a poor materials, and due to a poor constructions, and due to design problem, due to overload or excess load is applied on a structure, or that is happening if the once the designing a construction, the future load also will be estimated. But if it is exceeding those future load, then it will create a damages in the concrete structures. Then after knowing the various reasons of damages in concrete structures, repairs of cracks usually does not involve a strengthening, because whatever the loss of strengthening, that is only gained by the repair process or repairing technique. And repair generally repair is nothing but it is a process of restoring the damages or deterioration or broken structure to it's a good condition. So that is the definition of repair. So in every structure the repair is needed, because in every structure the damages or the deterioration or the destruction will be happen. So due to that a repair is required. So the repair is required for the purpose of to enhancing the lifespan of the concrete structures. So repair of a structure showing spalling and integration, and it is usual to find there have been substantial losses of a section, or pronounced corrosion of the reinforcement. See, not only these three defects, and we have a another type of defect also is there, that is corrosion. So if the spalling of the concrete will be happen, which means the layer will be out from the concrete structures, then the steel is exposed to the moisture condition or environmental condition. Due to that there will be a corrosion of the steel will be happen. The repairing of cracks. So how to repair the cracks, whether the crack is active or whether the crack is dormant, which means it is a not active stage. So first you need to identify whether the crack is dormant stage or whether the crack is non whether the crack is active stage. So in order to determine whether the crack are active or dormant, periodical observations are done utilizing various types of telltales. So which means whether the crack is active or dormant, you need to observe the periodical observation, which means which is done by a maintenance stage. So we have so many maintenance is there, preventive maintenance, corrective maintenance, repetitive maintenance. There will be lot of maintenance is there. So maintenance is required. Those are will be weekly maintenance or monthly maintenance or yearly maintenance. So is required to know whether the crack will be active or dormant. So by placing a mark at the end of the crack, so where the crack is there, so that you mention the end of the crack, where whether the crack is stopped at a particular position, you need to place a specified mark on that position. So a pin or toothpick is lightly wedged into a crack and that it falls out if there is any extension of the defects. So once the marking is done, if any extension of the crack, you need to identify it with the help of a pin or a toothpick. And a strip of notched tape work is similarly same. The movement is indicated by tearing of the tape. You need to identify when how much of the crack is extended. So the devices using a typical vernier calipers is the most satisfactory of all. So when you compare it to the tape, vernier calipers is giving a more accurate results for checking the extension of the crack. So both the extension and compression are indicated in vernier calipers. So if more accurate readings are desired, extensiometers can be used. So as for the accurate purpose, not only in the vernier calipers, extensiometers are also used. Where extreme accuracy is required, resistance strain gauges can be glued across the crack. So resistance strain gauges also is there. So types of cracks in masonry structures. So up to now we discussed it, what are the types of damages or what are the cracks present in the concrete structures. Now what are the cracks present in masonry structures. So various types of cracks is there, which means vertical cracks, horizontal cracks, diagonal cracks, shrinkage cracks, random cracks. See what type of cracks is presented at what location will be identified based upon the visual observations and a lot of tests. See first one, a vertical cracks. Vertical cracks will be appear in side walls at corners. So in that place or corners or side walls of the in building structure, vertical cracks are developed. And vertical cracks not only the side walls of at corners and also around the balconies and below the opening end line and the window jambs, and vertical cracks at the junctions of RCC column and masonry walls. In RCC columns and masonry walls also the vertical cracks are developed, and vertical cracks is the topmost stories at the corner of the structures having RCC slab. So mostly the vertical cracks are developed at the corners at most of the regions. Corner region, most of the vertical cracks are developed. Next, coming to the horizontal cracks. Horizontal cracks are developed at the position of at a window lintel or a still level in the topmost story. Or horizontal cracks also develop in the topmost story below the RCC slab level also. And roof and joints and purlins also. So majority horizontal cracks develop at window length due to the horizontal cracks due to lateral pressure is developed, then that time horizontal cracks will be produced. The random cracks also is there, which means in all direction involve both external and internal walls and external walls. The random cracks, which mean in all direction the cracks will be produced or developed. And diagonal cracks over a arc spanning a large openings. And shrinkage cracks, shrinkage means the change in the volume of the concrete structures, then that time there will be a shrinkage cracks are produced. Then how damage occurs in brick masonry structures? See, what are the reasons? Now we discussed what are the types of cracks in masonry structures. Now this time, so how those cracks are produced, which means what are the reasons? What are the reasons? Those are the rain exposure and temperature fluctuations, moisture observations, chemical alternations, and continuous exposure to chemicals. If the rain exposure to the bricks or masonry structures, there will be some type of cracks are produced. Temperature fluctuations and moisture absorption, chemical, these are all the reasons of damaging of brickwork. And the next, constructional errors, not only the environmental problems for the damaging of brickwork, and also constructional errors also is there. What are those? The eccentrical loaded walls gives overturning effect. If the eccentrical load walls means the load which is not act at a middle of the structure, the load which is acting away from the section, then it is called as a eccentrical load. So eccentrical load wall gives a overturning effect. And decorative panels on one side, supporting of working platform on one side, then usage of poor quality materials and error due to saving in economy. So these are the constructional errors for the damaging in brick masonry structures. Then later, general causes to develop the cracks, not only the constructional errors and not only the environmental errors, and these are the also some reasons. Poor quality of bricks are used for masonry works, use of porous stones are used, then absence of grading in before the use of fine aggregate and fine mortar. And these are all related to the general causes of developing the cracks: weak mortar, insufficient bond, improper curing. This is also whenever during the construction, if any fault or if any mistakes in the construction of brick masonry to develop the cracks. And then move on to the diagram. It indicates, we already discussed in the concrete structures, where the crack is developed, which if it is a active cracks, it will be not a stopped at one position, it will be also extending from some distance to stopped position. So first diagram indicate marked end of crack. So if it is a dormant stage, which means it is an inactive crack, the crack ending position will be at a particular ending position. But if it is a active cracks, the crack will be extending. The second diagram, which will indicate a pin where the crack is developed, specify a pin or some tool is used. The next, notches tape, notched tape also used, and gauged points also used, indicate the these are all are the telltales. Now the types of cracks. So we already discussed types of cracks, mainly active cracks or dormant cracks. Active cracks means it is a continuously the crack is developed. Dormant crack is nothing but the crack is stopped at one position, which means it is old and it is a new type. The proper differentiation between active and dormant crack is one of the magnitude moment, and telltales are measured the differences. And if the magnitude of the moment measured over a reasonable period, which means 6 months or 1 year, is sufficient to displace or show the significant on the telltales. We already discussed the telltale diagrams. We can treat the crack as an active one. So this is the active. In case if the movement are smaller, the crack may be considered as a dormant. If the moment of the crack will be smaller or stopped, the crack will be indicated as a dormant stage. If the magnitude of the movement over a reasonable period, for example, 6 months or 1 year, so if it is continuously moving, that type of crack is comes under the group of active crack. Cracks can also divided into solitary and isolated cracks and pattern cracks also. So generally solitary cracks means it is due to positive overstressing in a concrete, or either due to load or shrinkage. So if the load is increasing, there will be a solitary crack will be produced, or if it is a shrinkage happen, which means the volume is changed, then that time solitary cracks due to shrinkage also. And overlaid cracks are fairly easily identified because they follow the lines and demonstrate in the laboratory load tests. Overload cracks also easily identified because of using laboratory tests. So in long retaining wall or long channel, the regular formation of cracks indicate the fault in the design. So in the retaining walls or long channels also, the type of cracks are developed. So if it is a irregular distribution of solitary cracks, which may be due to the loads and shrinkage, not only the solitary cracks, and regular patterns of cracks may be occur in the surface of the concrete and thin slabs. So these are called as a pattern cracks.